Alright everyone, welcome to the next lesson. And this lesson is going to be everyone's favorite worded problems, so application questions. I know everyone loves it. That's what we're going to do today. Again, I have no clue what the answers to any of these questions are. I had a colleague of mine make these questions. So what I want you to notice is not just the answer to these questions, but the way I approach it, okay? The way I attempt these questions is really important. Alright, let's get started. So let's read this first question. Water is being poured into an empty reservoir at the rate of 8 liters per second. Give the rule for volume V after t seconds after the water is first starts to be poured. Alright, that's interesting. Notice what I did there. As I read the question, I underlined what I thought was the important information. So I want you guys to do that as well from now on. So let's think about this. So there's an empty reservoir. Okay, so I'm going to draw a reservoir. There's empty at the start. And there's water being poured in at the rate of 8 liters every second. Every second. So what does that mean? 8 liters every second, right? 8 liters per second. That's what it means. So pretty much if t is equal to 1, so if time is 1 second, how much water is in there? Well, volume is going to be 8 liters, right? If t is equal to 2, what's the volume? Volume is equal to 16 because it's 2 times 8 liters. And likewise, if t is equal to 3, volume is equal to 24 liters, right? So I think you guys can see the rule now. What's the rule? Well, the volume is going to be 8 multiplied by t, right? So if t is 1, it's 8. If t is 2, it's 16. And if this 3 is 3, then it's 24. So that's how the rule works. So the answer to this part A is V is equal to 8t. All right, next. So part B, it's the same as up there, what I've written down here. So another reservoir initially holds 300 liters of water, right? And the water is being poured in at the rate of 3 liters per second this time. Okay, give the rule for volume V liters after t seconds. Okay, again, let's draw a diagram. Notice how I'm drawing diagrams to help me. Again, that's another important tactic you can use to help you solve these questions. All right, so this reservoir is not empty at the start. Initially, it has 300 liters of water. Then water is being poured in at the rate of 3 liters every second. Every second. So if t is equal to 0, guys, so at the very start, how much water is there? Well, there's 300 liters of water. If t is equal to 1, well, there's 300. How much? There's extra 3 liters of water being poured in. So volume is equal to 303. If t is equal to 2, volume is equal to 306 because it's 3 times 2 liters of water being poured in. So what do you guys think? Pause the video and write down the rule, okay, if you think you know the answer. The rule is this. Volume, initially there's 300 liters of water, plus every t second, there's an additional 3 liters of water being poured in. So t multiplied by 3. So that's how I get this relationship happening. That's the answer to part B. Okay. Part C asks, sketch both graphs on the same axes. We'll have two graphs. Graph 1 is V is equal to 8t. That's the first reservoir. And the second graph is V is equal to 300 plus 3t. Okay, so you have two graphs to worry about this time. So what you guys are probably not used to at this stage is actually, it's not y-axis and x-axis anymore, right? Because there's no y and x in this variable. Let's rewrite these equations. For example, I can write equation number 1. I can write it as y is equal to 8x. Okay, so that's more what we're used to. And the equation number 2 is y is equal to 300 plus 3t. So 3x, sorry. 3x. So do you notice what I did? I replaced the t's with x's and I replaced the v volume with y, right? So what I'm trying to get you to understand with this question is it's no longer y-axis, x-axis. It's actually v for volume because the vertical axis is v. So your y variables are going to give you volume. Likewise, your x-axis is no longer x-axis, actually. It's t-axis, t. Okay, where time is measured in seconds. And I forgot to put here, volume is measured in liters. I think that's how you spell liters. It might be L-I-T-R-E-S. I don't know. I have no clue. I hope you guys know that. Again, this is not an English class, so I'd have to teach you that, luckily. All right. So I hope you understand. I'm going to say it again. Your y-axis, your vertical axis is volume, whereas your horizontal axis, your x-axis is t for time. Okay? So again, you don't have to worry about sketching these. If you're more comfortable, we can think about sketching these ones. So how would you sketch y is equal to 8x? Well, if you try to find x and y intercept, you'll notice x-intercept and y-intercept is 0, 0. So it goes to this coordinate. Again, if you remember the other lesson, if it goes to 0, 0, well, we have to sub in our own coordinate, x equals 1, for example, to get the y coordinate, and sub this back in. So y is equal to 8 times 1, y is equal to 8, so the coordinate is 1 and 8. Okay, so if you remember, We did these sorts of sketching in the previous couple of lessons ago, few lessons ago. So you have 1 and 8, for example, 1 and 8, and remember you just connect the dots, like so. Boom. Okay. Next, we need to sketch this graph. So y is equal to 300 plus 3x. So remember, if it's like this, then you find x-intercept, y-intercept. To find the x-intercept, we're going to make y equals 0. 0 is equal to 300 plus 3x. Negative 3x is equal to 300. X is equal to negative 100. I just did that quickly. So negative 100, let's say, is roughly around, I don't know, like it's here somewhere. I'm just guesstimating. Y. I don't know if guesstimating is a word, but I just made it up on the spot. So I hope it's a word. Guesstimating. All right. Y-intercept, x equals 0. You can tell straight away y is 300. So the intercept is 0 and 300. Okay. So let's say that is, I don't know, again, guesstimating here. Let's put that there roughly and connect the dots. Boom. So you can see clearly we have 0, 300 and negative 100 and 0. All right. But that's not the full picture here, guys. Because remember what I said? I said volume. The y values represent volume, right? Y values represent volume. So, for example, if over here my y value, let's say, is 500. For example, if my y value is 500, that means the volume in the reservoirs is going to be 500, right? So, can you guys tell me something? Can volume be negative? Can I have a negative 100 volume? No, it doesn't make sense at all, right? So, what I'm going to do is actually anything below the x-axis is going to give me a negative volume. So I'm going to get rid of all the parts in this graph where they go below the x-axis, right? Because that doesn't make sense. I cannot have negative volume. Doesn't make any sense. Okay. Likewise, okay, what about time? Right, remember I said the x values represent time. For example, here, if t is equal to 100, for example, that means in 100 seconds, my volume is going to be roughly this. Okay, that's kind of the logic I'm going with. So likewise, can you tell me, can I have negative time? In other words, can my x values be negative? Can my t values be negative? No, I cannot have negative time, right? So anything to the left, right? Anything to the left of this axis, I need to get rid of. Left of the y-axis, right? Simply because I cannot have negative time. That's the only reason. So what you're left with is just in the first quadrant, right? That's all that you're left with. All right, so that's it. That's the sketching part done. I hope you understand that one. Okay. Was there a part D to this question? Oh, there was. Okay. Find the time where both reservoirs hold the same amount of water. So remember, guys, just a quick note. We used y and x to sketch it, but our equations are literally v and t, right? I just made it into this form to help us sketch it because you guys are used to y and x when you're sketching. That's why I just rewrote it. But our actual equations are this: v is equal to 8t and v is equal to 300 plus 3t. Those are our two volume equations. So it's asking, okay, V1 then V2, let's say. It's asking time where both reservoirs hold the same amount of water. What the same amount of water means is pretty much means the volume in the first reservoir should be the same as volume in the second reservoir, right? So that's it. And then we need to solve for time, okay? Well, where do we get time from? Well, I know that V1 is equal to 8t, so I can replace this with 8t. And I know that V2 is equal to this whole thing, is equal to 300 plus 3t. From here, I just need to solve for time. So if I take 3t to the other side by subtracting, I'm going to have 5t is equal to 300. And t is equal to 300 divided by 5, which is 60. 60 seconds, right? 60 seconds. I forgot how to spell seconds. S-E-C-O-N-D-S. Okay, I think that's seconds. All right. Quickly moving on. 60 seconds, you can also write as 1 minute. So pretty much, you'll notice, right? If you sub 60 into this, or this, you're going to get the same amount of water in both reservoirs. So if we were to talk about it graphically, that would be this coordinate here, where both of them intersect. So that would be, for example, time would be 60. So this is 60, and the volume would be, well, it would be, let's actually find the volume. How do you find the volume? For when time is equal to 60, you can sub it into either this equation or this equation. I'm just going to sub it into here. So volume 1 is equal to 8 multiplied by 60, which is 480 liters. Okay, so then the corresponding volume over here would be 480 liters. So this coordinate is 60 and 480. That's where they intersect. All right, so that's part D done. I hope you understand that question. All right, so now it's time for you to have a go. Okay, pause the video and have a go at question 2. All right, let's do this together. Shaq is driving his G-Wagon from LA to his house, which is 50 kilometers away. The speed that he's going is 120 kilometers per hour. Wow, Shaq is going really fast. He loves sending it. All right. It says find the distance of Shaq from his house d kilometers in terms of time, t hours. It should say t hours. My bad. My apologies. Time t hours after leaving. Okay. Let's do this question. Let's draw a diagram. Again, with distance, speed, and time questions, guys, always best to draw diagrams. So this is LA, so that's where Shaq starts. And all the way he goes to his house. Shaq's house. So this is how far away? Well, this whole thing is 50 kilometers away. We need to find, let's say let's pretend Shaq is, driven for like, I don't know, 5 minutes. And let's say he's at this point here, right? So we need to find an equation for distance from his house, right? It's asking distance from his house, which is from the point where he's at. So this point till his house. Okay, maybe let's start by finding how far he traveled between here and here. Let's say the first part of the journey, he took time is equal to t hours, right? Because that's what the question is saying, time t hours. Let's say the time he took is t hours, okay? What is his speed? Speed is equal to, 120 kilometers per hour. Right? If you have time and speed, remember our distance, speed, time questions, distance is equal to speed multiplied by time. We can get the distance that he traveled by just multiplying these two, speed multiplied by time. So the distance that he traveled just in this first little part, distance is equal to 120 t. Okay, so this little part over here is 120 t. That's the distance that he traveled. But that's not the distance we're solving for. The distance we're solving for is this whole thing. Like I said, the distance from his house is what we're finding. Well, some of you might already know, if this whole thing is 50, if we just subtract the 120t, well, we're going to get this distance here, the distance to his house. So let's do it. So the distance, the final answer, the distance to his house, d, is equal to 50, which is the total distance minus how far he traveled. Already traveled, it's 120t. And that's it. That's how you get the equation. Okay. Part B is asking to sketch the graph of Shaq's journey. So again, distance d, I'll just write it here, distance is equal to 50 minus 120t. Okay, again, remember, if I rewrite this with y and x, it will be like this. Y is equal to 50 minus 120x. So what's my y variable? My y variable is actually d kilometers. And what's my x variable? My x variable is going to be t, not in seconds this time, t is in hours. Okay, so x is t, y is d. All right, so let's sketch this graph. Again, so how do you sketch these graphs, guys? You find x and y intercept. We've done plenty of these questions, so I'll do it quickly. X intercept, you make y value 0. So 0 is equal to 50 minus 120x. Take 50 to the other side. Negative 50 is equal to negative 120x. Make both positive. And then x is pretty much divided by 120, so 50 over 120. If I can cancel out the zeros, so I can just say x is equal to 5 on 12 hours. Okay, 5 on 12 hours. It's fine, it's a fraction, but we can handle the fraction. So let's say 5 on 12, I don't know, it's roughly over here. Again, guesstimating. My made up word. I don't know if it's made up yet. I want you guys to find out. Guesstimating. Search it up and see if it's a real word. Alright, lastly, y-intercept, I guess it's in mx plus c form, so you should be able to tell it's 50 already. But I'll do the equation. Y-intercept, x is equal to 0. So then y is equal to 50. If you guys do it, you'll get 50. So the coordinate is 0 and 50. So let's say that's about, I don't know, let's say it's here. 0 and 50. Again, if you have a proper axis with like numbers on them, like 30 and 40, put it there properly. But I don't have axes, like I don't have numbers on it, so I'm just guesstimating. Alright, so this whole journey, then how do you sketch this graph? Well, you just draw a line through both coordinates, sketching the graph, like so. Okay, again, we're going to run into the same problem, guys. Can Shaq, so distance, remember the y values this time represent distance. So for example, over here, this y value is 40, for example, that means he's 40 kilometers away from his house. If y value is 20, then he's 20 kilometers away from his house, right? That's what the y values are representing. So, can you tell me, can I have a distance of negative 20? Do you think Shaq's going to go past his house and keep going? No, it doesn't make sense, right? In this question, it doesn't really make sense because the question says he's going to his house. So pretty much, you can't have negative distances. So you're going to get rid of everything below the horizontal axis, the t-axis this time. So what I'm going to do is get rid of everything below, like so. And likewise, can I, again, t, the horizontal axis, the x values are representing time. So for example, if this is equal to half an hour, right? It's in hours. Then yeah, that's he's been traveling for half an hour. So can I have a negative time? Can I have time is equal to negative half? No, it doesn't make sense. So likewise, we can't have anything to the left, right? Because my x values cannot be negative. So pretty much I need to get rid of all of this part here. So anything to the left of the x-axis, you just get rid of. Boom. And that's it. Okay, you sketch out the graph. So this is this whole journey over here. Shaq's journey. Okay, so that's sketching there. Oh, I forgot to label the x-intercept. Make sure you label. It's very important. So x-intercept was 5 on 12 and 0. Okay, you sketch the graph. Next question. How long does it take Shaq for him to reach the halfway point in his journey? Okay, what does the halfway point mean? Well, how long is his whole journey? His whole journey is 50 kilometers, right? His journey from LA to his house is 50 kilometers. Then, right, what's half of 50? Because the halfway point is going to be halfway, which is half of 50, which is 25 kilometers, right? 25 kilometers. So then, we know our equation. Our equation is D is equal to 50 minus, what was it? 50 minus 120t. 120t. We know that's our distance. So then what we should get the time for which he's 25 kilometers away from his house. So it's simple. All you have to do is sub 25 in and solve for time. So we can say 25, that's the distance, how far away he is from the house, is equal to 50 minus 120t and solve from there. So take 50 to the other side by subtracting, you're going to get negative 25 is equal to negative 120t, make them both positive, and then divide by 120. So 25 over 120 is equal to t. So we need to simplify this fraction. So time is equal to 5 goes into 25 5 times, 5 goes into 120, 10, 20, 24 times, right? So that's the final answer, 5 over 24 hours, right? So if I was to, that's how long it takes for him to reach halfway. And if I were to do it graphically, it will be roughly, halfway in, so pretty much half of 5 on 12. So 5 on 24. And when he's 5 on 24, he'll be roughly, 25 kilometers away. So this would be 0 and 25, for example. So this coordinate is 5 on 24 and 25. Okay, that's how we got there. Graphically, I'm just showing you. Okay. Part D. At what time does Shaq reach his house if he starts the journey at 9 p.m.? So guys, can you tell me, in which point in this graph, when does he reach his house? Well, he reaches his house when his distance is 0. When is his distance 0? It's pretty much the x-intercept of the graph, the t-intercept of the graph, right? So you can see, remember y values represent distance, so the y value is 0. So here our distance is 0. That's when he reaches the house. How long did it take him to do that? Well, x values teach us tell us how long it took him. So it took him 5 on 12 hours. Okay, so that's one way to think about it graphically. Or you can just do this, right? We know the equation is D is equal to 50 minus 120t, right? So when does he reach his house? Like I said, when it's 0, when distance is 0, distance from his house, 50 minus 120t. And so when this is pretty much our x-intercept. So the time that it took him was 5 on 12 hours. 5 on 12 hours to reach his house. Okay, so then his journey starts at 9 p.m. Okay, so we need to calculate 9 p.m. plus 5 on 12 hours. That's when he reaches his house. But 5 on 12 is a bit of an annoying number. So what I'm going to do is convert it to minutes. And to convert hours to minutes, I just need to multiply by 60 to go from hours to minutes. So 5 on 12 multiplied by 60. 12 goes into 12 once. 12 goes into 65 times. 5 times 5. So it took him 25 minutes to make the 50-kilometer journey. He really went fast. Okay, so when does he reach his hours? So pretty much we're doing 9 p.m. 9 p.m. instead of 5 on 12, it's going to be 25 minutes. So he reaches his house at 9:25 p.m. And that's the answer. Okay, hope you understand. Okay, that's it for this lesson. I'll see you soon.